So hello students, now for today you have again two questions based on series. Both are literally very important questions. So I believe at least first one तो देखिए second one is a trick based question, so trick is important but first one is concept based question. अच्छा इसमें of course ये छोटा सा correction है but आपको post में question corrected ही मिला होगा. Okay, so let's start with the first one. First one में आपकी जो series है, you have to solve for this series which goes from n 1 to infinity. It is sine of nx over 2 raised to the power n. And see, what I always tell to my students that if you get a series and we can't apply any formula directly, then the first thing I go for is to expand the series, just to have a feel that in which direction is it going, or does it give any hint to us while expanding it, while looking at the terms when we are expanding it. तो देखिए ये तो पक्का दिख रहा है कि डिनोमिनेटर में तो आपकी चल रही है जीपी. व्हाट अबाउट न्यूमरेटर? न्यूमरेटर में प्रॉब्लम ये है कि द एंगल विद इन साइन इज चेंजिंग. अच्छा, एक थ्योरम है बच्चों ऐसी कॉम्प्लेक्स नंबर में, जब भी आपको एंगल विद इन साइन और कॉस एपी टाइप में या एंगल चेंज हो रहे हो लाइक साइन 2x साइन 3x साइन 4x, you should always remember de Moivre's theorem. What does it say? It says if you have cos theta plus iota sin theta raised to the power p. What is it? So it's cos p theta. The power gets multiplied in the argument in the angle theta and that's it. Okay, तो जैसे ही ये क्वेश्चन सामने आया, so one thing struck my mind is de Moivre's theorem. अब point ये है कि what shall I assume, with what to start? So I will say okay, let us start with summation of cos x plus iota sin x by 2 raised to the power n. N goes from 1 to infinity. Now look at it, just expand it. तो जब n को आप 1 रखेंगे तो cos x plus iota sin x by 2. Then put n is equal to 2. What will you get? De Moivre's theorem, cos 2x plus iota sin 2x by 2 square. Now similarly, when you replace n by 3, you will get cos 3x plus iota sin 3x by 2 cube and so on and so on. So if you compare this with the required series S, what can we claim here? We can say that we need its imaginary part. So therefore, S is nothing but imaginary part of this series. Which series? Cos x plus iota sin x by 2 whole raised to the power, and I believe all of you will agree to me. मानते हैं बच्चों सारे? सारे बच्चे ठीक है? तो ये डन. अब देखिए इसको आप यदि ध्यान से देखें, ये सीरीज कौन सी है? ये इन्फिनाइट जीपी है बच्चों. So imaginary part of infinite GP cos x plus iota sin x by 2 plus cos x plus iota sin x by 2 whole square plus cos x plus iota sin x by 2 whole cube and so on and so on. So it's infinite GP. Infinite GP का sum कितना? It is a, the first term over 1 minus r. R the common ratio. So first term is cos x plus iota sin x by 2. Isn't that accepted? R is again same, cos x plus iota sin x by 2. बस इसको आप सॉल्व करिए, इसका इमेजिनरी पार्ट निकालिए और आपका आंसर आ जाएगा. सो लेट मी क्विकली सॉल्व इट. सो दिस इज नथिंग बट इमेजिनरी पार्ट ऑफ, सो ऊपर तो यही रहा cos x प्लस आयोटा sin x, and in denominator you get 2 minus cos x minus iota sin x. Now it's a child's game. Okay, to just realize the denominator. Realizing the denominator means like we say for rationalization, I call it realization. Okay, so converting this denominator to a real number, so multiply and divide by its conjugate. So when you multiply in the numerator by the conjugate of the denominator, so that's what we get here, है ना? Okay, and then in the denominator we always know z into z bar. So this is a complex number multiplied by its conjugate, it gives us mod z whole square. So what is it? 2 minus cos x whole square plus sin square x, which I think is 2 plus 4 sine 5 minus 4 cos x. So that's what we get in the denominator. So it's imaginary part. How much is it? So we multiply this with this. So 2 sine x minus sine x cos x plus sine x cos x. Okay, so I think it's 2 sine x simply upon 5 minus 4 cos x. That should be the answer for the series. So that's my answer for the series. So that was the first question. Now quickly move to the second one. सेकेंड वन एज आई सेड इज अ ट्रिकी वन, तो इसको अच्छे से ध्यान से समझ लीजिए. इट माइट बी हेल्पफुल एट सम अदर प्लेस. सो a goes from 1 to infinity, b is another variable independent of it, goes from 1 to infinity, ab upon a plus b whole factorial. Now what to do? you will you should say, okay, let a plus b be some number p. Okay, now that means I can replace either A in terms of BP or B in terms of AP. So I will write B as P minus A. So now, therefore, if I say this to be series S, so S can be written as, see, A is still goes from 1 because A is still a variable. Okay, because I'll be replacing B by P minus A. And in new denominator, you get P factorial. See, the beauty of this assumption is that in denominator you had two variable within factorial, it got converted to single variable, which we can take care of very easily, bachcho. Okay, but the point is how to write the limits. Now the minimum value of p is, when a and b both get 1, the minimum value of p is 2. So p goes from 2 to infinity and a goes from 1 to p minus 1. That's important. Why? Because a is nothing but like p minus b. Okay, so minimum value of b is 1, so the maximum value of p minus b will be p minus 1. So that's it. So now just move ahead. So ये हो जाएगा आपका, this is, I'm not putting it, so it's ap a upon p minus 1 factorial minus a square upon p factorial. Now see what happened. You have two different variable and you can have two different summation. Okay, so you can solve it, simplify it stepwise. How? So you will say, okay, s is um this is 1 upon p minus 1 factorial into summation of a. Summation of a is p minus 1 and into n plus 1, so p by 2. That's 1 minus 1 by p factorial into summation of a square, which is pn, which is p minus 1, into n plus 1, which is p, into n 2n plus 1, which will be 2p minus 1 upon 6 whole within this summation. So now we need to simplify. So this gets cancelled. So this is half times summation of p over p minus 2 factorial. Okay. Then this is minus 1 by 6 times summation over p minus 1. So it's 2p minus 1 by p minus 2 factorial. I think all of you will agree with me. Isn't that? मानते सारे बच्चे? ठीक है. अब हम यहाँ पे क्या करेंगे? देखिए, अब ये किस फॉर्म में जा रहा है. ऊपर वाले p से आप बस मुक्ति पाते चले जाइए. तो आपने यहाँ पे लिखा p minus 2 plus 2 upon p minus 2 factorial minus 1 by 6, and you take 2 common here, or rather it's okay. Okay, so 2 times p minus 2, so it's 2p minus 4 plus 3 over p minus 2 factorial upon p minus 2 factorial. Agreed? So what do we get? Half times summation. For the first term we get 1 over p minus 3 factorial plus, of course, summation 1 over p minus 2 factorial minus 1 by 3 times summation 1 over p minus 3 factorial minus half times summation 1 over p minus 2 factorial. Now, in which direction are we going? We are going in the direction of exponential series. Okay, so let's simplify this and this together. What do we get? I think we get 1 by 6 summation 1 over p minus 3 factorial plus half times summation 1 over p minus 2 factorial. Now that's perfectly okay, because if you open this one particularly, so I'll write half times, start with p is equal to 2, because the lower limit of p is 2. Okay, so start with p is equal to 2, you get 1 by 0 factorial, which is 1, plus 1 by 1 factorial, plus 1 by 2 factorial, plus 1 by 3 factorial. Which series is it till infinity? This is nothing but e, so half e. But here see, p can't start with 2. Okay, p minus 3 factorial, negative factorial is assumed to be 0. So p will be starting with 3 here, of course, and that's the domain restriction here. So this one you can say it's 1 by 6 times, and then this is what? Of course, e again. So this is this plus 1 by 6 e. Now you can simplify. I don't think there will be any calculation error. If it is so, doesn't matter. What matters is the method. Okay, so that's the beauty of this method or the question, that if you assume a plus b by some new variable p, you can convert it to the form which we can then easily simplify. But okay, so those were the two questions for today.